The first step is always look to remove any common factors. Okay, removing a common factor is really just the process of distributing, but in the reverse direction. So if you have a sum or difference of terms, and there's a common factor between those individual terms, you will remove that. Here you'll take out that common factor of a, and whatever you're left with is going to have the exact same form as what you started with. So if the original expression is a binomial, when you remove your common factor, you'll still be left with a binomial. And so you do want to check that as you go through the process. Okay, so I want you to really quickly try this first problem before I talk through it. What do you remember being, or what do you remember from your algebra class on removing a common factor? When you do factor expressions, you will tend to have your polynomial written in standard form, which is your highest degree, written first. And even if you have a negative number as your leading coefficient or as the leading term, you'll generally remove that negative too. So here when we look at these two terms, so again, we're dealing with a binomial, keep that in the back of your mind. Because when you remove this common factor, you should be left with a binomial as well. So looking at this, what common factor can we remove from the numerical portion of each term? Negative 6 and 14 have a common factor of? And you take out the negative, right? So if the leading term is a negative, remove a negative as a common factor. So you have a negative 2. And when you look at the variable part, you have a common base r. If you have a common base between the factors or the terms, you'll always take out the lesser power. Okay, so the lesser power means it sits further to the left on the number line. And now, for positive numbers, it's usually not an issue, but if you do happen to have negative powers, thinking of it in terms of furthest to the left on a number line generally helps. But here, which of these numbers is lesser, 4 or 3? Power of 3, right? So this is your common factor, negative 2r cubed. What that means is when you remove these common factors from the individual terms, you should be left with a binomial. Okay, so let's look at our first term. Take out a negative 2. What numerical factor are you left with in the first term? Negative 6 is a negative 2 times 3, so we're left with the 3, right? We remove that negative 2, meaning we divide it out. Okay, and then r to the 4th, if you have r to the 4th, we're removing r cubed from that. If we remove r cubed, how many r's are we left with in that term? Again, the r cubed comes out, leaving just the r. When you remove it, you're dividing, and the rule for dividing exponents, if you divide exponents with the same base, what do you do with their powers? Dividing exponents with the same base, you subtract the powers. So 4, the original 4 minus this 3 that we remove leaves 1. Okay, move to the next term. Positive 14, if we remove a common factor of negative 2, that's going to leave negative 7. Okay, and if we remove all 3 of these r cubes, there's nothing left inside. So it's just the 3r minus 7, and that would give you your factored form. Okay, now, this is the first step that you should do for all factoring problems. It's also the last thing you should do before moving on. Just double check and look. Anything that's not a monomial factor, verify. Are there any common factors between 3r and negative 7? If there are, remove them. But if not, you can move forward. But it's the first step, but you should also think of it as the last step as well. All right, so once you remove common factors, then you have to determine whether your expression or your polynomial has 2 terms, 3 terms, or 4 terms. Okay? If it has 2 terms, then the next test you should do is to see if it fits one of the factoring patterns for 2 terms. We're going to talk through 2 of them here. And those patterns are the difference of 2 squares and the sum of 2 squares. Okay? If you see 2 perfect squares with a subtraction symbol between them, what you're going to look to do is apply this pattern. The difference of two squares, a squared minus b squared, will factor into the sum and difference of the bases being squared. So if we have base a squared minus base b squared, it factors into the sum of a and b times the difference of a and b. So again, this is a pattern that you should be very familiar with. Okay, now this pattern doesn't work if it's the sum of two squares. So a squared plus b squared does not factor into a plus b quantity squared. And we'll get to that at the bottom of this slide. Okay, the a plus b quantity squared is going to have this middle term when you expand it out, and so you have to account for that. A squared plus b squared is said to be irreducible over the reals. This means that in the real number system, there are no factors of a sum of squares. Okay, once you guys get to imaginary numbers, you can rewrite the factors. But that won't happen until next year. Okay, so a squared plus b squared, all you're looking to do is remove any common factors. Then when you get to that step, if this is what you recognize, there won't be any further factoring that you can do. All right, so if we look at these two examples here, see if you can factor the first and second problem on the right-hand side. So step one, always remove any common factors. So when we look at these two terms, 49t squared and negative 100, are there any common factors you can remove from those two? No. Okay, so then you look to see, does it fit one of the patterns? Well, 49t squared and 100 are both perfect squares, right? 49t squared is the base 7t squared, and 100 is the base 10 squared. So once you recognize that it fits this pattern, you now have the factored form of the sum and difference of these bases. So the bases are 7t and 10. So 7t and 10, it factors into the sum and the difference of those, and so this would be your factored form. Okay, so it's just about recognizing the patterns for that. Okay, for the second example here, look to remove any common factors first, and what you see is that they do have a common factor of a 2. So we can take out a 2. When you take out a common factor, what's left has to have the same form as the original, which is a binomial. Right? We have the sum of two terms. So taking out a 2 from 2w squared leaves the w squared. Taking out a 2 from the positive 32 leaves plus 16. Now notice that you have a w squared and a 16. These are also two perfect squares, right? W squared and 16 is 4 squared. Okay. Does the sum of squares have a factor pattern? No, the sum of squares does not. It's only the difference of squares. So that means that there's no additional factors you can remove from this other than that common factor of 2. Okay. Right. There's another pattern with two terms that's the sum and difference of cubes. We're not going to talk about that at this time. Okay. If you go through and you remove any common factors and there's 3 terms, okay, you should look for a special factor form first. The special factor form is this one. If you recognize that your first and last terms are both perfect squares, where you have a base a squared and a base b squared, what you want to do is you want to test and see. If you take that product and double it, do you get this middle term? So a times b doubled is 2ab. If it fits this pattern, then you have a binomial square. The binomial square would be a, b, and the sign between would be whatever the sign is of the middle term. Okay, so this would be your factor pattern if you recognize perfect square trinomial. So here's the process for looking at something like this. If we look at this example, first you remove any common factors from all the terms. Between 64q squared, negative 144q, and 81, there is no common factor to remove. And so we move on. We have 3 terms. Test to see, does it fit this pattern? This is the only pattern at this point that we have for 3 terms. Is it a perfect square trinomial? The way that we find that is look at the first and last terms. Are these perfect squares? 64q squared is the base 8q quantity squared. 81 is the base plus or minus 9 squared, right? It can be either positive 9 or negative 9. The way that we determine which one it is looking at the sign of the middle term. The middle term is a negative, so that means that the only possibility would be a base of -9 quantity squared. And so let's test it. We can test to see if this is a perfect square trinomial by taking the product of the bases. 8q times -9 is -72q. And double that. If we double that, do we get this middle term, -144q? Yeah, -72q times 2 is -144. So that means that we have a binomial square. The terms of our binomial are 8q and -9, and that would be the factored form. All right, so those are the patterns that you would be looking for after you remove any common factors. So that's, again, the order that you should progress through factoring. Remove common factors, check for the patterns. If there is no pattern, or once you complete the pattern, you're then going to check the following. Or if it's 4 terms, so again, we looked at what happens if there's 2 terms, 3 terms, and now 4 terms. If there happens to be 4 terms, you'll use a process called factor by grouping. Okay, so let me talk through this here, and we'll kind of go through the process, or we'll go through the example on this given problem. Okay, so if you recognize 4 terms, remove any common factors from all 4 terms. So there is none in this. And then you're going to follow this process. You're going to group each pair of terms and remove any common factor. So a pair means 2. So we're going to take all 4 of these terms and we're going to split it into 2 pairs of 2. Okay, so if I group each pair together and then remove any common factors. So from the first pair of terms, 3r cubed plus 18r squared, what common factors can I remove? Numerically, I can remove a 3. And then variable-wise, they both have a common base r with the lesser power between the 2 and the 3 as 2. Once I remove my common factor, what remains has to have the same form as what I started with. Because I grouped it into a pair of terms, it needs to be a binomial. So 3r squared removed from 3r cubed leaves what for the first term? R. And 3r squared removed from 18r squared leaves what for the second term? 3 comes out of 18, leaving 6. So here's your binomial that remains when you remove your common factor. Do the same thing with the second pair. So 10r plus 60 has a common factor of 10. What's left has to have the same form, 2 terms, a binomial. So if you remove a 10 from 10r, you're left with r. And if you remove a 10 from 60, you're left with 6. Now, if you've done this correctly and it's factorable, what you should see is there is a common binomial factor here. And we see that. R plus 6 is a common binomial factor. So the next step here is to remove that common binomial factor. So I take that out front. And what's left is going to be the monomial factors that are in front of each group. Okay? And so when I look at this, these remaining monomial factors, are going to be the terms of the other binomial. So notice here, when I take out the r plus 6's, I'm left with a monomial factor of 3r squared and a monomial factor of plus 10. So 3r squared plus 10. Those become the terms of my other factor. Okay? And so this winds up being my overall factored form. And that is the answer. Now, what you would look to do here, just like with all the others I had mentioned before, is check to see, are there any common factors you can remove from any of these remaining factors? So r plus 6, no. 3r squared plus 10, no. We don't have rules for factoring that. Okay? There's no other factors you can remove. Again, it's a good idea to check that one more time because you might have missed it on the first time through. And if you double check it, you'll catch it before you move on it or you hit submit. Okay, so this is the process called factor by grouping. This is going to be a step of one process that we're going to use in this last set of practice problems. Okay, so we will come back and we'll use this process again in the next slide. All right, so that's the main gist of it. If you remove common factors, if it's a binomial, check for the difference of squares or the sum or difference of cubes when you get to that. If it is a trinomial, check to see is it a perfect square trinomial that has a binomial square factors, or is it 4 terms, and check to see can you factor by grouping. If none of that works, then you move on to the next step, which is you're probably going to have a trinomial. And if it's not a perfect square trinomial, you're going to use one of these 2 methods to solve. So the first one is, let's take a look at what happens when your leading coefficient is a 1. So this is the easier way to do this. And if that's the case, you're going to use a process called reverse FOIL. Reverse FOIL is just trial and error, although there's a process that you use for this. And reverse FOILing just means if you have x squared plus bx plus c, you're looking to see what terms can you sort of reverse engineer so that when you FOIL them and expand them, you get the original expression. So here what I'm doing is I'm looking to see if I take the first, the outer plus inner, and the last, and I reverse engineer this polynomial. What 2 possible factors, when you multiply them together as first terms of the binomials here, can give you t squared? Well, the only possibility is t, right? T and t. Next, we go to the last term. What are the factors of this last number, positive 56, whose potential sum is equal to the outer and inner product? So if we look at 56, including the sign, okay, what are some factors that we can look at that give us a total sum of negative 15? Well, the product is positive. That means that the signs are the same. The middle term is a negative number, so that means that those same signs have to be negative. So we know that these are negatives. And if you just start testing them, now I'm going to start by just looking at negative 1 and negative 56, negative 2, and negative here, if you look at this, 28. If you just start right there, you can continue to work through and test all the different possibilities that you could possibly have that would give you this overall product of 56. More than likely, you're going to do this with just some mental calculations, right? What 2 factors of positive 56 have a sum of negative 15? Negative 7 and negative 8, right? When you look at that, they multiply to give you positive 56. They add together to give you negative 15. So once you find what those are, those just become the constant, or the terms of the second terms of each binomial, and that is your factored form. Okay, so reverse FOILing when the leading coefficient is 1 is the process that you use. Okay. Now, what happens when the leading coefficient is not 1? When that happens, you have a choice. And you can use one of 2 methods, okay, by hand to factor this. So let's look at the first method. The first method is the same thing. It's reverse FOILing or using trial and error. Okay, so now you have this leading coefficient in front of your term. So you're still going to use the same idea. Okay? If you just test the different possibilities that you can multiply to give you ax squared, and then the second term of each binomial factor would be the 2 factors that give you an overall product of c, then you can just find what works from that set. So if we look at this problem right here, and we approach it using trial and error, reverse FOILing. The 2 possible values that you can multiply together to give you 10p squared would be 10p and p, but also 5p and 2p, right? Those are the 2 possible things that when you FOIL it, those would give you a first term of 10p squared. Move to the last term. So negative 3, if we want to find what possible numbers or factors of negative 3 can you have? You would have a positive 1 and a negative 3, a negative 1 and positive 3, positive 3, negative 1, negative 3, positive 1. So because the sign is negative, we have to consider all those possibilities, and we have the same combinations here. Plus 1, negative 3, minus 1, positive 3, plus 3, negative 1, negative 3, positive 1. So here are all the different possibilities, and trial and error process means we're just going to start going through these, and we're going to FOIL them and see which ones give us the outer and inner product of positive 13p. Okay, so let's look, and we're just foiling this. So we take the outer times or plus the inner products. So 10p times negative 3 is negative 30 plus 1 times p is 1. So is negative 30 plus 1 equal to negative or positive 13? No. Here we get positive 30 minus 1. No. Here we get negative 10 plus 3. No. We get positive 10 minus 3. Nope. So we move to the next combination. Here, when we take our outer and inners, we get negative 15 plus 2. Does that equal positive 13? No. But what about positive 15 and negative 2? Yeah. So there's our combination right here. Okay, we had 8 possible combinations to test. We solved it on the 6th combination of testing, and so our answer is 5p minus 1 times 2p plus 3. Okay, and so that would be your factored form. So most students probably are most familiar with this process, okay, using the trial and error method to reverse FOIL. There's a second method that you can use. And now what I've done here is I'm going to use this same problem here, and I'm going to walk through this second method. Notice I added another page. I just embedded a page here because I'm going to use a little bit of that to show this relationship. Okay, so I'm going to take that 10p squared plus 13p minus 3, and I'm going to factor this again using the rewrite the middle term method. Okay? So let's look at that process here. Either of these work. You can either use trial and error or rewrite the middle term. Again, to me, I prefer this method unless I see that the leading coefficient and the constant are prime numbers. If I know that there's just a few combinations, I might test that. Okay, but if you're going to rewrite the middle term, here's the process. Again, it's all based on having the form ax squared plus bx plus c, because I am going to refer to a as the leading coefficient, the coefficient of the second degree term x squared, b is the coefficient of my first degree term x, c is the constant. Okay, so the first thing I'm going to do is I'm going to look to take the product of a times c. So here I have 10 times a negative 3. That gives me negative 30. And I'm actually, since I have room here, I will write that right below my middle term. Okay. I'm then going to test this to see, can I find factors of that product? So I'm going to refer to that as, can I find factors of step number 1, whose sum is the middle term's coefficient? And that middle term's coefficient is b. Okay, so are there 2 factors of negative 30 whose sum is this middle term, positive 13? So if you just start testing it here, right? So negative 30, if I want the sum to be a negative, I have one negative sign, one positive sign. Since, again, the sum is a negative number, that means that the larger of the 2 numbers has to be my negative. So here I have 1 and 30, that's not it. 2 and 15, is that it? Yeah, or actually I have the sign. I think I talked through it wrong. So I know that I have a positive 13 for my middle term. Okay, and so when I take the sum of these, I need a positive number for this. So my larger number is going to be the positive. So I have, again, my tests are negative 1 and positive 30, negative 2, positive 15. And once I get to this point, I see that has a total sum of positive 13. Once you find what those factors are in step 2 here, what you can do is you can rewrite your middle term, which is why that's the name of this process. As the sum of these factors. Okay, so instead of writing it as 13p, I'm going to rewrite it as negative 2p plus 15p. Okay, and by doing that, I can now drop my first and last terms down. 10p squared and minus 3. And then I'm going to factor by grouping. So I'm going to group together each pair of terms. What common factor can I remove from this first pair of terms? Between 10p squared minus 2p, I can remove a 2 and a p. Taking out a 2p from 10p squared leaves a 5p. Taking a 2p out of a negative 2p leaves negative 1. Do the same thing for my second pair of terms. Between 15p and negative 3, I can remove a common factor of positive 3, leaving a 5p and a negative 1. If I've done this correctly and it's factorable, I should have a common binomial factor, which I do, 5p minus 1. And the remaining monomial factors of 2p and positive 3, 2p and positive 3, form the terms of my other binomial. And so that would be my factored form. I see it's the same thing as I got by trial and error. And now, what if when you saw this, you had written it as positive 15 and negative 2? What if you were just writing your positive, happened to be writing your positive numbers on the left, your negative numbers on the right? If we had rewritten this as 10p squared plus 15p minus 2p minus 3, if we dropped the first and last terms down and we factored by grouping here, is this going to change anything? When we look at this first pair of terms and remove a common factor, we can remove 5p, leaving 2p plus 3. From my second pair of terms, there's no other factors in here, so I do have to account for something, so I take out the sign, negative 1. If I remove a negative 1 from each term, this leaves a positive 2p and a positive 3. If I've done this correctly and it's factorable, I should have a common binomial factor, which I do. And the remaining monomial factors of 5p and negative 1 form the terms of my other binomial. And do I have the exact same thing? Yeah. So it doesn't matter. Like the nice thing with this method is it doesn't matter. It's going to work all the time. And you don't have to pay super careful attention to it. You can just write them down. All right. So I want you to try, notice I changed the problem. Okay, I want you to try this problem right here. Can you factor 10x squared minus 23x plus 12? Using either of those methods. You can either reverse FOIL or you can rewrite the middle term. Okay, I'm going to show you both here so you have some options, okay, but I want you to try whichever method you feel works for you. Have any of you been exposed to this second method before? Okay, so it looks like most of you are kind of still confused on that second method, right? So because most of you are using the first method, which is not bad, and I'm going to go through the first method first, because I do want to show you that sometimes on the first method, you can reduce the number of combinations that you even try. Okay, so let's look at the first method here, and I'll kind of show you like some shortcuts for that. So the first method is, can you just use trial and error and reverse FOIL this? So if that's the case, you're looking at first product of first terms of 10x squared. There's two possible combinations for that, right? There's 10x and x, and there's 5x and 2, 2x. All right, so those are your only possible first terms. Okay. However, a positive 12 has quite a few combinations of factors. Luckily, it's a positive number, which means the signs have to be the same. And since the outer and inner, the sum of the outer and inner is a negative number, you know that those have to be negatives. So we don't even need to consider any positive factors there, right? So all we need to do is look at all the possible combinations that give us 12 that start with negatives. So negative 1 and 12, negative 12 and 1, right? Flip them. We have negative 2 and 6, 6 and 2. We have 3 and 4, 4 and 3, and then we get back to 6 again and kind of work our way back up. So these are all the different possible combinations to test here. Well, we need to test those combinations in both. So 1, 1, 12, 12, 1, 2, 6, and 6, 2, 3, 4, and 4, 3. All right. So if this is the process that we're going to use, okay, rather than just start testing right now, there's another way that you can eliminate some of the possible combinations. Notice here, when we're looking at these, we have 6 combinations for each one. So that's a total of 12 combinations we'd need to test. Not impossible, okay, but there is a way to minimize or reduce this down. And that is, when we looked at this, or when you look at the original function, okay, the very first step for all factoring is, can you remove a common factor? So when we look at those 3 terms, is there any number that we can remove as a factor between 10x squared, negative 23x, and 12? There's not, right? What that means is that when we go in and factor it, there cannot be any common factors between the individual terms of our factors. And so here's where that makes it easier. If we look at this, the first factor, 10x minus 1 times x minus 12, there's nothing that's inconsistent there. But what about the second, 10x minus 12? If 10x minus 12 was the correct factor, then that means we should have been able to take a 2 out, right? Because a 2 is a common factor between both 10x and 12. So what we know is that we don't even need to consider that combination. Same with the next one, right? 10x minus 2. If that were correct, then we would have been able to pull that 2 out earlier. 10x minus 6, same thing. 10x minus 3 and x minus 4, I can't remove anything from that. So that one's, we do need to test that one. But 10x minus 4, I can eliminate. Go through and look at the next ones as well. So 5x minus, there's no, on this left side, there's no other numbers that are share a factor with 5x. So I can't cancel anything there. But 2x minus 12, if that were correct, I would have been able to take a 2 out of the original polynomial, which I can't, so I can eliminate that. 2x minus 1, no, but 2x minus 6, 2x minus 2, 2x minus 4, I can eliminate all of those. Does everybody kind of see what I did there by eliminating those options? And so now instead of me having to test 12 different combinations, I now have reduced that down to 4. Now there's only 4 possible combinations that could even work on this. And so if we test those, here I get a negative 120 minus x. Not going to work, right? Here I get a negative 40 minus 3x. Not going to work. So I come down here, I get 5 times 1 is negative 5 minus 24. Nope. And then finally, negative 15 minus 8 is negative 15 minus 8. That is my answer. So my factors wind up being 5x minus 4 and 2x minus 3. Okay, so if I'm going to do this, or if I'm doing a problem like this by trial and error, that's the process I would use. Now, what would I do if I was trying this same thing and going to use the process of rewriting the middle term? Okay, so if I take my leading coefficient times my constant, so 10 times a positive 12 is 120. Are there 2 factors of 120 whose sum is negative 23? Again, they both have to be negative signs. And so if I start looking at this, because the total sum is an odd number, I know that one of my factors has to be odd, right? So when I start looking at factors of this, I would start testing some odd numbers that would work for this. So if I'm testing odd numbers here, I get 3 and 40. That's not going to be anything. Here, if I take and continue to look at some different factors, combinations that you can remove, I have a negative 5 and here negative 5 goes into 12, 20 with 2 remaining, so 24. Does that give me my combination that I'm looking for? No. Okay, and so if I continue to look through this, would be a negative 8. When I look at negative 15 and negative 8, I do get my total sum of negative 23. So here is my middle term. If I rewrite, my middle term is the sum of these two factors. I can bring down my first term and my last term, and I can factor this by grouping. What common factor can I remove from my first pair of terms? 10x squared and negative 15x have a common factor of 5 and x, leaving a 2x minus 3. From my second pair of terms, I can remove always the sign, but between negative 8x and positive 12, I can remove a negative 4, leaving a positive 2x and a negative 3. If I've done this correctly and it's factorable, I should have a common binomial factor, which I do. And my remaining monomial factors of 5x and negative 4 form the terms of my other binomial, and I get the same